It's so exciting, what we're going to see today. My name is Rasmus. I'm the founder and CEO and European Climate Pact Ambassador. And when we were here last time, I also had the wonderful pleasure to be up here, and I talked about a lot of things. Some of it I just want to brush up. And then I also challenged Michael and the IMPA SAVE, saying, is it really good for the environment when you have plastic bottles, or is the Tetra Pak better? Because there was no data. We had a lot of assumptions that this was better than that. So naturally, Michael and the team came back and said, okay, challenge accepted, Rasmus. Find the data, make the data. Let's see the numbers. Let's see what is it actually on the climate side that we are saving from a scenario. So this is some of the things I will talk about today. If we move over, let's just summarize a little bit. Where is it that many ship owners are, and also procurement companies? We see a lot of companies starting over here, joining initiatives, doing some ESG, figuring out what is the risk. We just saw a wonderful presentation about that. Now, when it comes to strategy, action, data is needed. We know that from the financial with the budgets, right? So this is the exact same once we are looking at the climate. We need data. And data is not just something we make up. We need to create the building blocks. And there is a company called Greenhouse Gas Protocol, or a initiative. And here they talk about something called scopes of emissions. I'll just do a brief introduction about what that is in a little bit. But once you know your scopes of emissions on a product, on a company, on what you buy or what you sell, or what you consume on board, then you really have the building blocks. Because then you understand what is it? What is the climate emissions generated? Once you know that, you can start all this magical stuff. And this is what we're going to talk about today. When we talk about the plastic bottles, we talk about the Tetra Pak, and we talk about this machine over here. Because these are some of the actions that you can do as a ship owner, as a procurement professional, but also as a sales or procurement platform. These are definitely some of the actions. So let's dive into it. Let's get some data. Let me just make sure we have all the prerequisites in order before I start mentioning a lot of lingo. So I mentioned earlier about scope 1, 2, and 3. So in a maritime context, scope 1 is what it's all about when we talk about fuel. These are the emissions generated from the vessel. Super important. I'm going to show you why in a little bit. Now we also see some vessels are using shore power. So this is what the indirect emissions from electricity, heating and cooling that is generated outside the vessel is called scope 2. And then we have everything else is scope 3. And these are really what we are when we are building the vessel, when we are having the operational side of the vessel with the maintenance and the consumables on board. These are all called scope 3 emissions. And these are the ones that are very difficult to put a number on because it can be very complex. So my hope is here today to take some of the complexity out of it, and let's dive into some of the numbers. Now, last year I pitched a little bit about why procurement is important. Today I dived into a little bit more data. So we have an example here with a vessel. This could be a profile of some of the vessels out there today. So these are the total emissions for this vessel in a 20-year lifespan. 2.5 million tons of CO2 equivalents. Now, how is that broken down today? Well, it is broken down to perhaps 80% scope 1. That is the direct emissions going out from the combustion of the fuels. But the fuels also have a supply chain. That means it's being produced, it's being transported. This is, again, what's called scope 3. And then we see the shipbuilding phase might be around 10% of the total emissions of the vessel. And the maintenance is very small today. Now, what happens if we start adding green fuel? Dun, 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 dun. When we start adding green fuel, you can see a significant reduction, about 75%. So we are on the right track. But we have not looked at the vessel itself. We have only optimized the emissions related to the fuel. So we have a task ahead of us, and that is optimizing the rest, and that's why we're here today. We need to start somewhere. We need to look at the shipbuilding. We need to look at the maintenance. We need to look at the consumables on board. Once we do that, we can get it down to the last 25%. Then we really have the key to break the net zero. Very good. So these were all the beginning of why this is important. Now, to measure emissions, and I'm sure there's going to be a presentation later on life cycle emissions and life cycle assessment from the UK Chamber of Commerce, so I definitely recommend that. So I'm not going to take all the fame right now out of that, but I think since it's a methodology that we have used in the study that you will see in a little bit, I think it will be prudent just to talk a little bit about what it is. And this could also be a teaser to later, right? So life cycle assessment is about assessing the emissions in the life cycle of a product or a process or even a vessel. So putting numbers on a product, why is it not just good enough to look at the construction of the product? Why do we need to look at the entire life cycle of the product? Now, a perfect example is these two cars, right? We've got a Tesla or an electrical car and a fossil fuel car. Now, we know if we only look at the use phase of those two cars, one of them is zero emission and the other one is not zero emission. But we also know that this car contains batteries. And we know that batteries are not the best thing if it's not recycled properly. So these are some of the thought seeds I want to plant in your mind. It's all about we need to look at the holistic side of it. We need to look at the whole life cycle of a product. And that's some of the challenges that we see today. We heard about it with the ESG, the whole risk side of it. We see that these Scope 3 emissions right now is a gray box. We see a lot of companies and a lot of ship owners that are just focusing on the fuel. Now, we do remember we need the last 25%, so we need to figure these Scope 3 emissions out. And the reason why we haven't looked at it is because we see a lot of supply chain complexity around it. It is very difficult to actually get the numbers. But that also falls down to the suppliers. As a supplier, you need to change the mindset. You need to start generating data to the ship owners. And the ship owners need to start asking for the data, right? So it is a chicken and the egg situation we're in right now. We all need to start. Now, some of the things that we can do with the life cycle thinking, I talked about the holistic viewpoint, informed decision making, and that is the thing we're going to look at today, is saying, now we have the data, now we know that one thing is better than the other. I'm not going to say which one is the best, but I'm sure you can imagine. We're also going to show you today about the hotspots. That means where in these three alternatives are the most emissions being emitted. And this is the way we need to think if we are to lower it on each of these. We need to look at the hotspots. This is where we should start when we put an effective decarbonization strategy in place. So using that, at ReFlow, we have some software. There's also other suppliers of software, but I'm just going to show that this has been calculated using our software that can calculate the emissions and so on. This is something that is needed. It's not just something you can do in a spreadsheet. So today, I'm going to say, okay, making the better choice. I think it's important we don't say the best choice. We say the better choice, because there will always be something better out there. It might just be so expensive it is not affordable. So making the better choice. So we've got the plastic bottle, we've got the Tetra Pak, and we've got the purified water. Da-da-da-dun. Let's dive into it, look at some data. So before we start looking at data, it's important we are very transparent about what are the assumptions and what is it we have looked at. So in this case, we have looked at the Tetra Pak and the water. It is being transported, in this case, 100 kilometers by truck into the factory. We have some truck transportation, 500 kilometers. We have some refrigeration. And then we have some recyclability of the plastic bottle at the end. And the same is done with the Tetra Pak. And we have a lower degree of recyclability because that is just how the standards are today. We're going to dive into it a little bit and try and tweak some of this to see what about the future, how does it look. And then we have the water purification machine. This has been sailed 18,000 kilometers by vessel. Whoa. And here it's good to be worst case, because I don't want to stand up here and you said, oh, this was not really how it was done. So let's say this is transported from Asia to Europe. or even back again, or some of it has been transported multiple locations in the world and then added together. Then we made some usage assumptions here. How much water will this generate a minute? How many liters can it produce a day? We looked at the refrigeration of the Tetra Pak and the water bottle. And then we have developed, used the methodology on using marine diesel oil for the power generation on board to make sure that electricity originates right now from fossil fuel. It's important to bring that into mindset, right? So doing all this, adding it in, looking at some of the data. Now let's try and look at some of the data. If we start over here with the plastic bottle, we can see that each half a liter of plastic bottle has about a carbon footprint of 0.15 kilo CO2. Doesn't sound a lot, right? But it is, and I'll show you. We can also look at some of the hot spots here. We can see the plastic. We can see the transportation is the second highest emitter after the plastic from the plastic bottle. So optimizing logistics is super important. I think we knew that already. If we look into the Tetra Pak, we'll see that it's 0.13, so marginal better. And here we can look at some of these scenarios. The biggest emitter from the Tetra Pak is the logistics. Okay, so if we can optimize the logistics, and some of you have already done that, I'm sure, then we can see there is some plastic mixed, and then we can see some different elements from the Tetra Pak having the emission in a sorted order. Now, this one looks super bad. And let me tell you why. Because this is the entire machine if you buy it and you only drink half a liter of water. This is the carbon footprint of the machine. That looks super bad. But nobody's just drinking half a liter of water in this machine. So this is why it could be good to look at the total consumption of a 20-year period of a ship crew and see how does this actually match up. Now, these are some of the data that I want to show you today. The gray one is the purification of the water. These are the volume of produced water or consumed water, and these are the emissions. So you can see the dark blue one is the Tetra Pak, the turquoise one is the plastic bottles. And then you can see the purification. So actually we've got an economy of scale here also when you look at the emissions generated. So my question is, how many bottles do we need to break even with the purification machine? It's not a lot, right? We need to look down here. So let's try and get some numbers on here. These are the numbers, 345 plastic bottles. If you use more than that over a given time period, the purification is better. And I'm looking at some of you, and you know you're probably buying thousands of bottles at the time. So there is no excuse, because as soon as you make one purchase, you're already above by 3 times. So these are really the data that is interesting, because as a ship owner, you can also say, what is the difference between here and there? It's huge. So these are the savings. These are what we are actually missing out of in savings for not doing it. So 172 liters if you use plastic bottles. It's not a lot. It's probably a day consumption on board a vessel, perhaps even less. So let's look at the life cycle thinking of the total scenario of 20 people for 20 years. So these are the emissions. So you see almost 90,000 kilos of CO2, 95 here, it's marginal better, it's still better. And then we look at the total carbon footprint from the purified water. So these are actually some really savings that we can actually start looking at. And then 500,000 liters of bottles of these. And here we only got 365. So if you look at that, that's a lot. It'll probably be the whole entire room here of plastic bottles. Now let's try and dive more into this scenario, because you might challenge me and say, hey Rasmus, so the future, we're going to be better at recycling. We'll be better at recycling the plastic bottles. There are some EU initiatives that are coming up. By 2035, the recyclability of plastic bottles is going to hit 70%. It's called producer responsibility. Now, the Tetra Pak will also need to hit the 70%. So let's play around with that. You still see we're nowhere near the drinking water machine. Now, we're also not innovating on the drinking water machine. I'm sure energy efficiency in this one will go up over the next 15 years, like everything else that is connected to technology. Now, let's look at 100% recyclability. It's utopia, but let's say we are the best of the best and we can recycle 100%. Are we near? Not even close. So these are for some of the skeptics out there to say, even though we recycle 100% and the plastic bottles 100%, we are still not even close. And we haven't even looked at the recyclability of the water purification machine. So let's look at some of the end-of-life scenarios and see what are the amount of waste. And if you look at the waste generated for the 20 years, 20 people, you can see the emissions from the waste here, and here, and here, and here. So, of course, when you look at the weight, you will generate more waste per weight measurement. On the Tetra Pak, it's more dense. But you can also see what you get on the weight, you save in the volume. So there is a substantial difference. And now these are 1 liter bottles. This study was made on half a liter bottles. So here you also see a improvement. Very good. And once you recycle this one, you'll get 37.57 kilos of waste. It's nothing. So looking into the drinking water, the usage phase is the higher impact. So naturally, if we want to improve this machine, we want to look at the usage. That's the electricity generated on board. So there are 2 ways we can look at that. Either we can start innovating, and you can see here the usage phase is where you have the highest emissions. So either you can look at the power supply, how the power is generated, or you can make the machine more energy efficient. These are the 2 ways that I see. So let's play around with making the electricity greener on board. So the first one is, this is the scenario today, marine diesel oil. What if we are to add some other scenarios? Now, just for fun, I added gray methanol, because I was at it's crazy, I was at a very large classification society's reveal of their outlook for emissions or for the sustainability of the maritime industry. And for the first time I heard the word, it's okay, we're going to use some gray methanol in the transition period, because it is methanol and it's better. No, it's not. It's worse. You have to use 2.5 times the amount of methanol because the energy density is worse. So this is the proof of that. Just for fun, just to show that gray methanol is not the way we should go. But in the other hand, if we are to use e-methanol, we have a substantial reduction of 82%. So this is really good. Of course, there will be a marginal improvement with the traditional methanol, but it's nothing compared with the green methanol. So these were some of the data that I wanted to show you today. So the key number here is about 300 bottles of plastic water. Then it's more affordable to actually, on the climate side, to invest in one of these. Any questions? Because I think this was mind-blowing for me. I'm sure it was a little bit mind-blowing for you, but also great. We finally get some data and all this stuff. And of course, this data has been made by myself and the team, and we're going to offer it free of charge to the IMPA SAVE Council members to use in this whole action towards end the single-use plastic on board. Thank you so much.